Hello class, today we are going to learn how to name simple ionic compounds. But before we start, let's make sure we have two things. First, make sure we have to have our periodic table. Second, we have to make sure we have the SHIAM notes that I handed out to you last class. And once you have those two, let's get started and fill them in together. So there are two examples that we're going to go through. The first one is MgBr2. Now let's follow these steps and try to name the compound. Step number 1 tells us to name the metal ion. So looking at MgBr2, Mg would be our metal ion. Now looking at the periodic table beside you, Mg would be magnesium. Now step 2 tells us that to name the non-metal ion by ending the element name with the suffix IDE. So looking at MgBr2, Br is our non-metal ion. So looking at that on the periodic table, we'll find Br as bromine. Now, like what step 2 tells us, we have to change the ending to IDE. Now, where's the tricky part is that which one do we cut off? How do we add IDE? The trick is to take away the last two vowels. Here we have E and I. So I am going to isolate INE. And I'm going to change that to bromide. Instead of INE, I have the ending as IDE. Now, just to backtrack a little bit, just in case anyone forgot what our vowels are. Vowels are, let me write it down on top. Vowels are A, I, O, U, and sometimes Y. But in this case, Y will count towards that. So keep that in mind. Take away the last two vowels and then sub it in with IDE. Now the third step tells us to write the name of the compound. So we're going to take magnesium and we're going to take bromide and we're going to combine them together. Magnesium, bromide. And here we have our answers for the name of MgBr2. Now let's try the second example here. We have Li3N. First step, name the metal ion. So Li will become lithium. Step 2 tells us to name the nonmetal ion and change the ending to IDE. So N is nitrogen. Now remember, taking away the last two vowels. So E and O are gone, therefore all that are gone. So here we have nitride. Then we combine them together, we end up with lithium nitride. And that is our answer for the name for Li3N. Here are some questions for you to try, and the answers are posted outside my door. So make sure you check that out, and I will see you in class. Hello class. Today's lesson, we are going to learn how to write formulas for ionic compounds. So make sure you have your periodic table and the sheet to fill in, and let's get started. So the first example we have here is zinc nitride. First step is to identify each ion and its charge. Looking at zinc nitride, zinc, if you look at the periodic table, it gives you Zn 2+. Then nitride, remember, because it got changed from nitrogen to IDE, so it becomes nitride, it would become N, and nitrogen has a charge of 3-. Now, step 2 tells us to cross the ion charges and place them as subscript. So we are going to get Zn 2+ and N 3-, and we're going to circle the charges, and these are the charges that we're going to crisscross, like this. So keeping a Zn there and N there, 3 from nitrogen drops down to zinc, and the 2 from zinc going to drop down to here. Keep in mind, we don't move the plus or minus in there. We're only going to move the numbers. Number 3 tells us to reduce the subscript amount if you can, and remove 1 from the subscript because they're not shown. So we are going to rewrite this. So we have Zn3 and 2. Now 3 and 2 cannot be reduced any further, so we're going to keep it the way it is. So our final answer is Zn3 and 2. Now let's take a look at the next example. Here we have aluminum chloride. Aluminum is Al3+, and chloride is Cl1-. Similar thing to as what we did earlier, we're going to crisscross them. Here we have Al3+ and Cl1-. We're going to circle these charges. We're going to crisscross them, and you're left with Al1, Cl3. Now, notice that Al have a 1, so we do have to remove that 1. So our final answer becomes AlCl3. Now, here are some questions for you to work on. The answers are posted outside my door, so give that a try, and I'll see you in class. Bye! Hello, class. Today we're going to talk about how to write formulas of multivalent compounds. So let's recap what is a multivalent ion and multivalent compound. Multivalent, the word multi means that the ion consists of multiple charges. For example, iron, Fe, has a charge of 2+ and charge of 3+. And that is considered a multivalent ion. Now, with multivalent, we have to make sure we include Roman numeral as our answer. So here, that's kind of why, if you look at their example, it gives us iron 3 sulfide. Iron 3, the 3 means that this is iron is a charge of 3. Similarly, for lead 4, that is the charge of lead. Now, feel free to refer back to the PR table and the Roman numeral chart to help you with these questions. So let's get started with these examples. For the first example, we have iron 3 sulfide. So this first step is to identify each ion in this charge. So we have here iron 3. Because it's a metal, we're going to have a charge of 3, a +3 there. Sulfide is sulfur, and looking at the periodic table, it gives us S2-. Now, similarly to what we've done before, step 2 tells us to cross the ion charges and place them as subscript. So we're going to take Fe3+, S2-, and we are going to circle the charges. We're going to crisscross them. Remember, leaving the plus and minus behind, you're going to be left with Fe2, S3. And step 3 tells us to reduce the subscript amount if you can, and remove 1 from the subscript because they are not shown. Here we have 2 and 3, the subscript. They are the reduced form, so we do not have to reduce them. So our final answer is Fe2S3. Let's try another example. Here we have lead 4 oxide. Step 1 tells us to identify each ion. So lead 4 is Pb4+. Oxide is oxygen. So we have O2-. We're going to write them down, 4+, Pb4+, and O2-, and we are going to crisscross them like we did earlier. Then you're left with Pb2O4. Now, looking at this, I'm going to rewrite Pb2O4 over here. Now, 2 and 4 can be reduced. Similarly to 2 or 4 in math, as a fraction, 2 or 4 can be reduced to 1/2 or 1/2. Therefore, we could simply reduce this to Pb1O2. Or, remember, we don't write 1. Therefore, our final answer is PbO2. Here are some questions for you to try, and the answers are posted outside my door. See you next time. Hello class. Today we're going to learn how to write names for multivalent compounds. So recap from before, the word multi means more than one. So multivalent means an ion that consists of more than one type of charge. For example, iron has a charge of 2 plus and a charge of 3 plus. That would be considered a multivalent ion. And when it's combined with another element, it'll become a multivalent compound. So here are two examples that we're going to work on. The first one is Cu3P. Instruction tells us to identify the metal and the nonmetal. Cu is copper and P is phosphorus. Now, step 2 tells us to form more than one kind of ion by checking the periodic table. So we're going to take a look at copper, we're going to take a look at phosphorus and see which one has more than one charge. Now, copper, looking at the periodic table, copper forms more than one charge. Copper could form 1 plus and it could also form 2 plus. So now we have to decipher which one did this formula use. Did it use copper 1 or did it use copper 2? Step 3 tells us to determine the ratio of the ions in the formula. So looking at Cu3P, we know is that there are 3 of copper and 1 of P. So we know that P will have a bigger charge and Cu will have a smaller charge. Now, step 4 tells us to note the charge of the negative ion from the periodic table. So P, phosphorus, has a charge of 3 minus. Fairly big, is bigger than 2 and 1 as what we have here. So therefore, it follows the rule at the moment. Now, let's take Cu3P and we're going to follow step 5 and tells us to cross the ion charges and place them as subscript. We're going to kind of undo what we've been doing before, how we cross the ions. I'm going to take Cu3 and P here, and I'm just going to put that imaginary one that we normally erase. We're going to put it down there. And I'm going to write Cu up here and P up here. So we're going to take these values and we're going to cross them back over this direction. So the P1 is going to come up to 1 plus. Cu3 is going to come up to 3 minus. Of course, you're probably confused. How do you know it's minus or plus? Well, the left-hand side of the element will always be plus, and the right-hand side will typically be negative. And noticing that it matches, we know that our copper is 1. So therefore, our final name is copper. And remember, we have to put Roman numeral 1 phosphide. And don't forget to change the ending to IDE. Let's try it in the second sample. Here we have MnO2. Let's identify the metal and the nonmetal. Mn is manganese. Now, make sure you don't spell this wrong. Manganese is always often spelt wrong because students think that manganese means magnesium, Mg. So please make sure you spell it correctly and you find it correctly. O is oxygen. Now, step 2 tells us to write down different types of ions in any of these elements. So looking at this, Mn has 2 plus, Mn also has 3 plus, and Mn also has 4 plus. So in this case, there are 3 possibilities. Step 3 tells us to determine the ratio of the formula. So that means that there are 1 of Mn and 2 of O. Now note the charges of the negative ion for step 4. So oxygen is 2 minus. Now keep in mind, 2 minus. Step 5 tells us to cross the ion charges and place them subscript. So we're going to do what we've done earlier. Mn, I'm going to put the imaginary 1, O2. I'm going to write Mn on top as well. and we're going to take these numbers and we're going to crisscross them and put them back on top. So you're going to end with 2 plus 1 minus. Now, here's what you're going to look at. O, do they match? And the answer is no. Notice that in this question, oxygen is 1 minus. Now, look in periodic table. Does oxygen have another charge? No. Oxygen has only a 2 minus charge. Therefore, because of that, this question must have been reduced before. Because it has been reduced, we have to multiply it again. So we're going to multiply both charges by 2. When we multiply both charges by 2, we end up with Mn4 plus NO2 minus. Now, this would match because O2 and O2 would match. And therefore, the Mn4 plus is the one that we need. When we write the name, it will become manganese 4 oxide. Now, please keep in mind you include the Roman numeral because if you forget, you will lose marks. Give some of these questions a try, and the answers are posted outside my door. Good luck! Hello class! Today we're going to learn how to write formula for polyatomic ions. Now, polyatomic ions are ions that are found on the back of the periodic table. So if you take a look at the back of the periodic table, that is where all the polyatomics are. These are ions that have more than one non-metal element bonded together to form a polyatomic ion. Now keep in mind, because they're bonded together, they exist as one. So here are 2 examples that we're going to do to go through writing the formula for polyatomic ions. We're going to start with iron 3 hydroxide. First step, identify each ion and its charge. Iron 3 gives us Fe3+. And then hydroxide, if you look at the back of the periodic table, it is OH1-. Now, step 2 tells us to cross the ion charges and place them as subscript. So I'm going to take Fe3+ and OH-, and we are going to take these 2 and we're going to crisscross them. And Fe, you're going to get 1, OH is going to become 3. Now, please keep in mind, I'm going to make a circle around OH because OH is together. Therefore, the 3 exists for the whole OH, not just for H, not just for O, but for both O and H. Now, let's note the number of positive ions and negative ions to make sure that this is actually balanced. So here we have 1 of iron 3+, so therefore a charge of 3+, and 3 of OH-, therefore charge of 3-. And notice 3+ and 3-, they would cancel out, it makes 0. Step 4, it tells us to use subscript and brackets to write the formula. Omit bracket if only 1 ion is needed. So let's put that together now. So here we have Fe, and ignore the 1, OH3. With the bracket, it tells us that there are 3 O's and 3 H. But if you end up writing this, that means there are only 1 O and 3 H's. So that would be wrong. So I'm going to erase that just so it doesn't confuse you. Let's try another example. Ammonium carbonate. Ammonium is NH4+, and that is found on the polyatomic side at the back of the periodic table. Carbonate, CO3 2-, also found on the same side. Now we're going to do the same thing. We're going to write ammonium 4+, CO3 2-, and we're going to crisscross the charge here. And keep in mind, because the 2 comes around, these 2 are together. So this 2 is out there. CO3, these are together. And then you're going to have a 1 here. Okay? That means there are 2 of NH4+, making that 2 plus charge, and 1 of CO3, 2 minus, making that 2 minus charge. Now let's combine them together and put the brackets in. So NH4, because they're together, we're going to put bracket and we're going to put 2. Keep in mind, because CO3 has a 1 outside, the 1 is technically could be neglected. We could take away the 1. Because of that, we just only need to write CO3, like what it tells us. Omit bracket if only 1 ion is needed. So here are the answer for the 2 examples. Now, I'll let you try these questions, and the answers are posted outside my door. So make sure you take a look and practice, practice. Hello class, today we are going to learn how to write names for polyatomic ions in ionic compounds. So there are 2 examples that we're going to work on today. Now just to recap, polyatomic ions are ions found on the back of the periodic table, and they are created by bonding 2 or more non-metal ions together. So the first sample we're going to do is CuNO3 bracket 2. Step 1 tells us to identify the metal ion with possible charges and the polyatomic ion. So Cu, looking at the periodic table, gives us a charge of 1 plus, and it also gives us a charge of 2 plus. Now NO3, that is found on the back of the periodic table, gives us a charge of 1 minus. Now, of course, we have to figure out which copper we're using, whether it's Cu1 or Cu2. So step 2 tells us to cross the ion charges and place them as subscript. So let's take a look. So I'm going to write Cu1 and O3, mimicking the question. And I'm going to write Cu here and NO3 over here. Now, of course, knowing that NO3 is a charge of 1 minus, I could write that down confidently. And I'm going to match that. If I cross them, will they match? And yes, thankfully they match. Now let's look at NO3. This has 2. Now if this goes up there, Cu will also be a charge of 2 plus. Now let's see whether copper is actually charged 2 plus by comparing the ratios of the positive and negative ions and see whether it will balance. 1 of copper, 2 plus, gives us a charge of 2 plus overall. And 2 of NO3, 1 minus, would give a charge of 2 minus overall. 2 plus and 2 minus cancels out, therefore we're balanced. So we know that our answer is Cu2 plus. Now let's write the name of the compound down. And remember, you do not need to change the ending to IDE. Just keep it whatever it tells us to on the back of the periodic table. So here we have copper, 2, nitrate. Notice I kept the word from the back as nitrate. I didn't change anything to IDE. Next example, Al2CO3, 3. So let's identify the metal ion, which is Al3 plus. CO3, found on back of the periodic table, gives us a charge of 2 minus. Now Al3 plus CO3, 2 minus. We could simply take that and crisscross that because there are only 1 charge of each. We can simply crisscross that and gives us Al2CO3, 3. And that matches with our answer. So we know that this is true. Now let's check it again to make sure the ratio is correct this time. So 2 of Al, 3 plus, would give us 2 times 3, which is a 6 plus, and 3 of CO3, 2 minus, would give us a charge of 6 minus. 6 plus and 6 minus cancel out, therefore this is balanced. So now to write the name of the compound, we would take aluminum And we will take CO3, which is carbonate, and put them together like that. And that will be our answer for the second example. Now, it is your turn to try these questions out. The answers are posted outside my door, so make sure you check on that. And I'll see you in class. Bye! Hello class, today we are going to learn how to name covalent compounds. Now, covalent compounds are different than ionic compounds. They are made by combining two nonmetal elements together, and during that point, they are sharing electrons rather than transferring electrons like ionic compound does. We are going to use prefixes to help us name covalent compounds. So, depending on the subscript number, it has different prefix. And prefix are little snippets of the word that are put in front of an element. So here we have a prefix of 1. So therefore, it would be mono. 2 would be di. 3 will be tri. 4 will be tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Now, feel free to refer back to this anytime you want. It's very helpful. Now, let's try 2 examples together. The first one is CO. Step 1 tells us to name the elements. So C would become carbon, and O is oxygen. Step 2 tells us to change the ending of the second element to IDE. So oxygen will become oxide. Remember that we are taking away the last 2 vowels. Step 3 tells us to add prefix to each element. And note, the first element will never have mono as a prefix. So looking at this, we have 1 carbon, 1 oxygen. That means that's monocarbon. Monoxide. Now keep in mind, it is 1 O, not 2 O. If it's 2 O, it will become monoxide. And for the English language, typically 2 vowels don't really exist together. Now, keep in mind, it tells us never have mono as the prefix for the first element. So because it says monocarbon, we're going to erase mono. And your final answer will just be carbon monoxide. Now let's try another example here. We have N2O3. N is nitrogen, and O is oxygen. We're going to change the second element from oxygen to oxide. And step 3 tells us to add the prefix for each element. Looking at this, N2 means there are 2 nitrogen. So we're going to use the word di. So dinitrogen. And O3, that means there are 3. We're going to use the word trioxide. That is our answer for these 2 examples. Now it's your turn to try these questions. The answers are posted outside my door, so happy trying! Hello class! Today's lesson we are going to learn how to write formulas for covalent compounds. Now remember, covalent compounds are formed by combining 2 nonmetal elements where they're sharing electrons. And we are going to use the prefix table that we wrote down before to help us with these questions. First sample gives us carbon disulfide. Step 1 tells us to write the symbol for both elements. So carbon is C and disulfide. Keep in mind di is the prefix, so we would just ignore that. And the element we're talking about here is sulfide, so which is S. Now, It tells us to place the prefix number as subscript for each element. Because carbon has nothing, we could simply assume that is a 1. And sulfur is di, therefore there are 2 sulfur. Now keep in mind, we don't write 1, so I'm just going to erase 1 here. And our final answer is CS2. Now let's try another example. We have carbon tetrachloride. Carbon is C, tetra is a prefix, and chloride would be Cl. So with C, because there's nothing in front, that means it's a 1. Cl is tetra, therefore that means it's a 4. And that will be our final answer. Now, there are some practice for you to try down here. Give that a try, and the answers are posted outside my door.